So you're thinking about rebuilding your 49 to 54 Chevy passenger car idler arm. Well, you're in the right place because I'm going to show you what I go through to get this done. Hi, I'm Jerry from Dr. J's Restoration RX and the filling station in Lebanon, Oregon. In this video, I'm going to show you how I rebuild the 49 to 54 Chevy passenger car idler arms. I've been rebuilding these idler arms for the filling station for the past several years, and I finally got it down to a procedure where I feel that they can last for another 50 to 70 years if cared for properly. At the end of the video, I will give you the information you need to contact the filling station to purchase one of these rebuilt idler arms. There is an exchange process involved, and the core charge is rather hefty, but this is because we want you to give back the original cores so that we can rebuild them for other customers. In this video, I'm going to show you the processes I go through in order to get this idler arm rebuilt. This is an intense project, and it's not one that you want to take on lightly because it's what keeps you from losing your steering on the road or having a very sloppy steering wheel. That said, let's go on to the video. These are the disassembled components of the idler arm I will be rebuilding. This particular idler arm assembly has a repair kit installed on it which won't be needed once the idler arm is rebuilt. So the first thing I'll do is remove this repair kit. This was an aftermarket kit that was available to take up the play after years of use. As this rebuild will eliminate any previous wear, this kit will not be needed. Once this is removed, I will remove the grease fittings and then knock out the cross pin that holds the idler arm pin to the frame and arm. What I'm doing here is removing the grease fittings and disposing of them, as I will put new 45-degree grease fittings into the arm once the build is done. Once the cross pin is removed, I'll use my air hammer with a custom chisel to remove the end grease cap. On this particular assembly, I was able to push the pins straight out the back side. Normally that's not a possibility because the pins will rust themselves into place, and I have to use my air hammer to knock the pin out along with the cap on the other end. It just so happens that the cap on the other end was already missing, so I was able to do this without having to knock it out. Now I'll do some quick cleanup to get rid of the excess grease before I press the bushings out of the frame. Here's a shot of the disassembled frame. And here's a shot of the disassembled arm assembly. I always install a new ball when rebuilding these arms. Here I'm drilling out the flared end of the ball about 1/8 of an inch deep so that I can press it out with my hydraulic press. Here I'm running the arm over the wire brush to get most of the heavy grease off before I put it into the solvent tank in order to get its final cleaning. Once the ball stud and arm are thoroughly cleaned, I will hammer the ball stud into the arm, set it into the vise so that it doesn't move while welding the two together. At this point, I'll do a partial weld to hold the two pieces together, and then I'll reposition the arm in the vise so that I can weld the rest of the perimeter. At this point, the arm is ready for sandblasting and painting. Now with the ball stud mounted to the arm, I'll give it its final bath in the solvent tank before going to the sandblast cabinet. Now with the arm ready for sandblast and paint, it's time to work on the frame. The first thing I do is use my sun and wrist pin press to press out the bushings with some special tooling I made to do so. This process is much easier than trying to hammer or cut out the bushings. With the bushings removed, it's now time to do the machining on the frame. In this clip, I'm using a reamer set to a specific size in order to take out the swedging for the original grease caps. This specific size is set so that the new grease caps that I will insert will go right in. I then take a carbide burr to the leading edge of the bore so that the bushing doesn't get damaged when it's being pressed in. Once this is done for both bushings, the frame is now ready for sandblast and paint. Now it's time to install new bushings into the frame. I use a special press tool and a Delrin insert between the two bushing areas in order to avoid damaging the frame. Before pressing the bushing in, I have to make sure that the grease zerk hole in the bushing aligns with the grease zerk hole in the frame. Once the first bushing is installed, I have to flip the assembly over and repeat on the other side. Over time, the intense pressure between the arm and the frame can cause a groove to appear in the surface of the frame. This groove can allow the arm to travel up and down while steering the vehicle, which can cause play at the steering wheel. What I'm doing here is machining the surface of the wear area to eliminate that possibility of the arm traveling up and down. Even with the use of steel shims, without flattening this surface, the arm can travel up and down on this surface. This is just one of the procedures I perform to ensure that the idle arm is removed from the possible reason that there's play in your steering wheel. Now it's time to check the runout between the arm bore and the pin. This is an important step to determine if I can use an original size pin or if I have to go to an oversized pin. In order to use an original size pin, the allowance is less than 30 thousandths of an inch runout. Once this is determined, I can move on to honing. This particular assembly is going to require an oversized pin, so I will show you the procedure I used to do the honing. I do the initial honing with a reamer set to a certain size to get me close to the final size I need. I only use this reamer on the brass bushings in order to get them close to the final dimension. The arm will need honing as well, but I can only do that on the sun and hone. I'm running the frame on the long arbor now to get the bushings to the final dimension. I will occasionally stop and check the pin for fit until it slides through the bushings smoothly. Once that happens, I can move on to the arm. Now it's time to hone the arm for the oversized pin. This is a bit more of an involved process as I'm honing steel instead of brass, and takes quite a while longer. Once I get the pin to fit the arm assembly properly, it's time to assemble the idler arm. Notice I have a shorter arbor on the machine now, and it has a better stone for honing steel. Before I assemble the idler arm, I'll chase the threads of the mounting holes with a 3/8 24 tap. Once this is done, we're ready to assemble. It's a little difficult to see in this picture, but I've installed grease seals on the top and bottom of the arm opening. I'm going to lubricate both sides so that it slips into the frame easier. Also down the bore of the opening. I also lubricate the bushings and the milled faces of the frame. I apply a couple of plastic shim stock pieces to avoid cutting the seals when I'm installing the arm into the frame. There are some sharp edges on the frame that can cut the seal as I'm inserting it. Once I have the arm safely in the frame, I'll remove one of the plastic shims so that I have room to put in metal shims. I will put in as many of these metal shims as I can after removing the rear plastic shim so that there's no up and down slop in the arm. Once I can no longer install any shims, then it's time to install the pin into the assembly. Now I'll put some assembly lube on the pin and mate it to the arm assembly. Once I get it in, I line up the pinholes and tap in the pin to where I can put the drift in the center hole. Once the pin drops into the center hole, then I know I'm ready to put the cross pin in place. Once I have the cross pin fully into the bore, I will inset it a little bit and then use a ball peen hammer to peen over the metal at the two openings. This will prevent the pin from working its way out in the future. Now I'll install soft plugs on both ends of the frame to retain the grease. I'll tap them into place until they're fully set, and then I'll use a center punch to swedge them into place. Next I'll use a hardened steel rod to expand the soft plug firmly into place. Once I've done this to both ends, then the assembly is ready for grease fittings and finally grease. Here's a shot of the completed assembly. Once it gets greased, it will be ready to sell to the customer. And this is a shot of the pin kit that I installed. So that's how I go about rebuilding these idler arms for the filling station. If you want to contact the filling station about these idler arms, I'll leave the information in the video below. If you want to contact me directly, you can do that as well. As you can see, this procedure is rather intense, and it does take some special tooling to get done. I've worked on it for many years, and hopefully these idler arms will be as good or better than the originals. If you feel you have the proper equipment to rebuild these on your own, you can buy the kits from the filling station. They come in standard or oversized kits. Thanks for watching the video, and I hope this has done you some good.